Hi there! In this lesson you will understand where image segmentation fits into an overall image processing pipeline. As you work through the labs, you'll gain a deeper appreciation of the type of pre-processing work we discuss here.
Okay, let's start at the beginning. Before we can segment an image, we usually need to denoise it, enhance contrast, and sometimes sharpen edges and things like that. And before that, we need to think about where our images come from. So I want to give you a brief appreciation of where image segmentation fits within a typical image processing pipeline. And then I'd like to briefly discuss some of the other image processing steps before telling you about the image pre-processing steps we'll use in our labs. So let's put image segmentation in context. We normally have a few steps to do before we can segment our image. Like the old French recipe for rabbit stew, first we must catch our rabbit. We need to acquire our images, typically from an image source, such as a camera, video, that type of thing. For our labs, our acquisition is kept as simple as possible. We're simply acquiring our images from file. But it's important to note that there may be a considerable body of work in choosing a camera or a video source. At the very least, for a real-world application, you'll probably care about spectrum, whether you're in infrared or visual, image size, resolution, field of view, price, and mechanical issues such as size and waterproofing, as well as connectivity, TCP/IP, frame rate, image format, and so on. Once we've acquired our image, we normally need to do some preparatory work on our image. The amount and type of image pre-processing typically includes some or all of the following: resampling, lens correction, artifact removal, grayscaling, lighting adjustment, deblurring, and denoising. Of these steps, in our labs, we'll be using grayscaling, denoising, and deblurring. So we'll come back and look at these again in more detail. After that, this is where image segmentation slots in, and this is the area we'll be concentrating on mostly in our lab work. After that, of course, for any real-world application, we then need to interpret the results. For example, if we've been using something like a canny edge detector for an autonomous driving application, we're hoping the interpretation is to stay between the lines and in our lane. Last but not least, there should be an outcome from this image analysis. In a medical imaging example, if we've decided there's a tumour in a medical image, hopefully there's a result where there's a course of treatment for that. Okay, so generally speaking, during pre-processing, there's often some work to be done before we can start to segment our image. And in our labs, we'll work through examples of this work. Often we need to resample our image. For example, we might need to downsample the image due to processing or bandwidth limitations. Our camera could be predefined for us, and often is, in which case we could have a 4K video feed at 60 frames per second to find pedestrians in. So in that case, simply for processor load, we might have to resample the image to 1080p and 25 frames per second, for example. Similarly, we might need to upsample an image. For instance, we could be dealing with a low-cost IR sensor with relatively few pixels, in which case we need to think about how we might upsample that image to fit what our algorithms are used to. Many of the common image segmentation algorithms operate on grayscale images, not full-color images. So, and we do this a lot in our labs, we often end up converting from RGB to grayscale. Similarly, often images are stored as BGR or other mechanisms and will need some preparation before we can use them. We might have to do a little contrast enhancement. So in this case, imagine we have a color image. We take the individual RGB values of each of the pixels in the image and plot a histogram of these values. If the histogram has space, and it typically does out at the edges, we can create a new histogram which more fully uses the available space, and map our original values into this new histogram. This results in more perceived contrast. Lenses are physical objects and are a whole field of study in themselves. They often have effects that need to be addressed. They can distort images, for instance spherical distortion, amongst a raft of other possible effects. Any individual lens can also have artifacts, part of the lens that are either dead or which work very differently to the other parts of the lens. And sometimes we need to correct for these effects. We won't get any further into that here, but it's worth noting that for any real projects you embark on, you may need to bear this in mind. We also may need to correct our image for illumination variations across the image. For blurring, and we'll see many examples of this in our labs, many of the image segmentation algorithms we will use are highly sensitive to noise. One way of reducing the severity of this problem is by running blurring or denoising filters across the image. These have the effect of taking out small sharp edges from our image. So what we're doing here is we're starting on the left with a grayscale image of starfish. Now let's look at this image as closely as we can to how a computer will look at it. We can probably interpret it as containing regions which are mostly white and black, with some black and white background. However, many of our segmentation algorithms are unable to read this image semantically and need to have the image simplified. So, for example, let's replace each pixel in the original image with the average of the value in the old pixel in the image on the left and all its nearest neighbours. That leaves us with the image you're looking at on the right-hand side of the screen, which is the filtered image showing, some noise removal. The takeaway from this pre-processing lesson is we will use image denoising in our labs, but for any real-world project you will probably need to solve some or all of the other issues mentioned here.
Okay, in this lesson we learned where image segmentation fits into an overall image processing application and gained an insight that there's some more software you'll need to write if you want to build a full application.